Hello, we are from group 20 and we are present the AirCoolerFan classification model and conditioner using a fuzzy logic approach. So our team member is Muhammad Afiq bin Fakurazi, normative is DI 230148. Second is me, Muhammad Fatuddin bin Mustafa. Normatric is DI 230059. And third is Lokman Nur Hakim bin Abdul Aziz. The number metric is DI 230136. And next is Alif Tio bin Muhammad Shukri Tio. Number metric is DI 230109. And lastly is Abdul Rahman Al Hafiz bin Sabri. Number metric is DI 230098. Because of the constant heat and the humidity in tropical nations such as Malaysia, preserving interior comfort is a big problem. Air cooler fans are widely used in home and business because they are less expensive and consume less energy than air conditioner. However, most present fan systems use a binary or threshold based logic to switch the fan on or off at certain settings. This causes abrupt change that don't represent the gradual nature of environmental change and human comfort.
Fuzzy logic control helps machines to make decisions like humans by using degrees of truth instead of just yes or no. It uses if then rules and membership functions. For example, if temperature is hot and humidity is dry, then fan speed is high. The system checks all rules to decide the best output. Fuzzification is the process of converting exact input values into fuzzy terms. In our system, we use room temperature and humidity as inputs. Each input is broken into linguistic values like cold, warm, or hot for temperature and dry, comfortable, or humid for humidity. These values are defined using overlapping triangular and trapezoidal membership functions. For instance, a temperature of 24 degrees Celsius might fall slightly into both the warm and hot categories. The fuzzy inference system uses a set of if-then rules to process the fuzzified inputs. It looks at combinations of temperature and humidity to decide the output, which is fan speed. For example, if the room is cold and dry, the fan speed will be low. If the temperature is warm and humidity is comfortable, the fan runs at medium speed. And if it's hot and humid, the fan speed is set to high. This rule-based logic mimics how humans make decisions. Defuzzification is the final step where we convert the fuzzy outputs back into a single crisp value to control the fan speed. In this system, we use the center of gravity method to calculate the exact value. The fan speed output is divided into three linguistic terms: low, medium, and high. Each has a defined percentage range. For example, low covers 0 to 40%, medium is 41 to 70%, and high is 71 to 100%. The system picks the most accurate value based on the combined output of the fuzzy rules. This is the center of gravity formula, which we use to perform defuzzification, also known as the centroid method. It calculates the balance point of the fuzzy output shape to give us one final crisp value. This method is especially useful in fuzzy control systems because it takes all the fuzzy values into account. In our case study, the temperature and humidity data are combined using this method to determine the exact fan speed needed.
Hello, my name is Muhammad Afiq. So I will talk about analysis and design. So for the analysis and design, we have a basic block diagram for air cooling fan, which is the input, activity, and the output. So for the input, we have room temperature, and humidity. And for the activity, we have fuzzification, fuzzy inference engine or rules, and defuzzification. And for the output is fan speed. All right, next we will talk about fuzzification, which is the description of air conditioner dataset. For the datasets, we have two names, which is temperature and humidity. So the values for temperature is cool, warm, and hot. For the humidity, dry, comfortable, and humid. So as we can see here, the input for two names back then, room temperature, cool, warm, and hot, humidity, dry, comfortable, and humid. So the output and the values for the output is fan speed and values is low, medium, and high. All right. For confidence value for temperature, input one, we have value which is start from 18 to 30, and membership function for input temperature, as we can see here, it shows the input temperature for the fuzzy logic system. The input consists of two types of graph, which are trapezoidal and triangular. The range is between 18 and 35. All right, confidence value for humidity, input 2. The humidity value, it start from 20 until 90, and the membership function for input humidity, it shows the input humidity for the fuzzy logic system are same as temperature. The input consists of two types of graph, which are trapezoidal and triangular. The range is between 30 and 90.
Okay. Assalamualaikum. My name is Alif Teo, and I would like to show our fuzzy inference system for air cooling fan. So there are two inputs for this project, which are temperature and the humidity. So this input will move to fuzzification phase, where it convert from crisp value to fuzzy value. After the fuzzification completed, it will move to fuzzy inference, where we get the rules for decision making in the fuzzy by the fuzzy value, where we can get the rules from the SME, and we'll move to next phase, which is the fuzzification, where we convert back the fuzzy value to crisp value in order to get the output, which is the fan speed. Now, I would like to show the system demonstration for our project. We are using MATLAB for the FRS, fuzzy inference system. So, in the MATLAB, we are using Mamdani Type 1. In air cooling fan case, the inputs are two, temperatures and humidity, and the output is fan speed. So let me show you the membership function graph first. So membership function graph for temperature is mixture of trapezoidal and triangular, with range from 15 to 40 degrees Celsius, with fuzzy term cold, warm, and hot. So next input is humidity. So for humidity, also it's look like temperature for the graph, but the range is from 20 to 90, and the fuzzy term is dry, comfortable, and humid. Okay, next I will show the rule editor. So for 3 inputs and 1 output, we can get 9 rule in total. So as an example, if temperature is cold and humidity is dry, then fan speed is low. So to get the defuzzification calculation, just press the rule inference here. Okay, now you can see the rule inference, where this is the two inputs, temperature and humidity, and we will get the output, which is fan speed. So in the MATLAB features, I can just simply enter the input and output. The two inputs, it will generate the outputs by using calculation formula for COG, center of gravity. So as example here, I put the temperature is 30 and the humidity is 50. So by pressing enter, the MATLAB will generate the output, which is fan speed is 50. It follow the rules number 5 from the 9 rules has been decided. So in the rule editor, you can see that it follow rule number 5 here, which is if temperature is warm and humidity is comfortable, then fan speed is medium in the rule inference. We can conclude all the input and output following all the rules that has been set in the control surface. So as you can see in this diagram, the vertical one is the output for the fan speed, and the horizontal one is humidity and temperature as the input. So this is all the outputs for all rule scenario. So that's all for the system demonstration. Thank you.
In conclusion, our project demonstrates how fuzzy logic can be effectively applied to automate a cooler fan speed control, especially in hot and humid climates like Malaysia. By using temperature and humidity as input parameter, our fuzzy logic system adjusts the fan speed intelligently and smoothly emulating human decision making to maintain optimal indoor comfort. Unlike traditional system that evolutionary, our controller offer a more adaptive and energy efficient solution. This project not only improve user experience but also shows strong the potential for integration into smart home environments. As future work, the system could be enhanced with additional sensor or mobile app integration and further optimized using machine learning to improve accuracy and adaptability. Thank you.